Hello friends, welcome to Suresh Agarwal's Mathematics Shortcuts. So what do we have in this video? Very important topic for class 10th Mathematics. This is the chapter number 11, that is areas related to circles. So when there is a circle and there are so many things we need to understand about circles. Various terms are there which we need to understand, and then how to find the area and perimeter of those figures which are related to circles. Areas of shaded figures, some portion of a figure is shaded and you have to find that particular area. All those questions come into in this particular chapter. So we are going to take up some of the short questions based on sector and segments. And first we need to understand what is a sector, what is a segment, and corresponding terms associated with this topic. So let's move on and do the sectors and segments part. So whenever you draw a circle and in the circle you take the center of the circle and draw any two radii. So suppose you draw this radius OA and another radius like this OB. So the portion of this circle which is intercepted between this arc AB and the two radii, this is known as a sector. This is known as a sector. And if instead of the two radii I draw a chord, say chord AB like this. Chord is a line which touches the circle at two different points, a straight line. It divides the circle into two halves, right? And this part is known as the minor segment because it is smaller than the semicircle. Minor segment, and the other part obviously is known as the major segment. Likewise, if you have a circle and you draw perpendicular radii like this, perpendicular radii of the in the particular figure, then the portion, this is obviously a sector, but this time it is known as, it is 1/4, right? It is a quarter circle and therefore it is called as a quadrant. So there are some formulas associated with these figures, the sectors, the segments and the quadrants. The first thing we need to understand is the sector angle. So if you see the figure here, so I am just rubbing off the shaded part. Yeah. So this angle which is inscribed by this arc AB at the center, this is known as the sector angle and this is denoted by theta, the sector angle. So to find the area of this sector, we need to use the unitary method. So if this angle is 360 degree, then 360 degree corresponds to an area of the entire circle, that is pi r square. So from here you can derive what will be the area corresponding to the angle theta. That will be pi r square times the angle theta upon 360. This can be derived using the unitary method, and one of the very important formulas for the chapter, area of a sector, pi r square times theta upon 360. Likewise, if you have a minor segment, then you need to understand that the area of the minor segment can be found out if you take this sector, the complete sector here, and subtract the area of this isosceles triangle from this. And for that I need this sector angle again, this is theta, and the radius. So for the minor segment, the area will be, I'll first take the complete area, that is the area of the sector, which is pi r square theta upon 360, and from that I am going to subtract the area of the isosceles triangle. And what is the area of an isosceles triangle? You should know this angle and you should know sine of that angle. So half r square, that is these two sides, product of these two sides, and both of them are r and r, therefore I have written r square, and sine of the angle between the equal sides, that is sine theta. So this forms the formula for area of a minor segment. The area of sector minus the area of the isosceles triangle. Half r square sine theta is to be subtracted. Now if they ask you to find the area of the major segment, then you can find the area of the minor segment and subtract it from the area of the circle. So I think that doesn't require any writing work here. This is the second formula. The third formula is that of a quadrant, which is very easy. A circle is pi r square, right? Area of a circle is pi r square. So area in case of a semicircle, that means half of that will be pi r square by 2, and therefore a quadrant, since it is 1/4 of the circle, then the area of the quadrant will be pi r square upon 4, and that is the next important formula. There's one more thing. If you have a sector like this, which is having a sector angle of theta, then we can actually find the length of this arc AB from A to B like this one, the one which I have darkened. This is called the length of arc AB. This is how you write it, length of arc AB. So you can actually find the length of arc AB, because if this angle is 360 degree, then length of arc is the complete circle. So for 360 degree it is 2 pi r, and so for theta you can use a unitary method again, 2 pi r times theta upon 360. Just like we used unitary method here to find the area using pi r square multiplied by theta by 360, here you use circumference, 2 pi r multiplied by theta upon 360. Now these are the formulas in this particular chapter, and most of the questions will revolve around these formulas only. So let's take some of the basic questions first, which are like very short answer and short answer type questions, 1 mark and 2 mark questions. The first one here is a problem of clocks. The minute hand, so whenever the length of the minute hand is given, this becomes the radius, because that is the line which is going to move from the center like this, and that becomes the radius of the circle. Now find the area swept by the minute hand in 1 minute. So the time is 1 minute. Now you should know that if you have the face of a clock and this is the 12 position and say this is 5, right? So in 1 minute the area swept will be like this much, and we need to find this area, and for that I need the radius of circle, because it is a sector. I need the radius and the sector angle. So where is the sector angle? For sector angle I need to use the basic concept of the movement of a minute hand of a clock. What happens in 60 minutes? In 60 minutes the minute hand moves one complete round, and that means 360 degree revolution. But now if I apply the unitary method, in 1 minute it will be 360 upon 60, and that is 6 degree. So in 1 minute time I have to take the theta as 6 degree, and this will give me the area swept by the minute hand, which will be the area of the sector, pi r square times theta upon 360. Now you can just put the values and get the answer. This is easy after this. 22 by 7 times 14 times 14 times 6 upon 360. So I can see a 7 cancelling out and a 6 cancelling out, giving me 60 here. And what else? There is 30, and this is 7, and so the 2 cancels out, 15 here. That's it. So this is 22 times 7, which is 154, and divide that by 15, you get your answer for that question. The area swept by the minute hand of the clock will be 154 upon 15 centimeters square. You can find that in decimals and get the final answer. Likewise, if you have a question where you are asked to find the perimeter of a sector. Now what happens with the perimeter of a sector? Let's understand this first. So if this is a sector, right? This is a sector. So if I want to find the perimeter of the sector, the entire boundary of the sector, right? So this is radius, and this part is the length of the arc. This is L, the length of the arc. So if I have to find the perimeter, I will do length of arc plus radius, or perimeter will be length of arc plus 2r. Now this is the formula which I am going to use to find the perimeter of the sector. Now the radius is 7 centimeter, so r is 7 centimeter, and central angle is 45 degrees, so theta is 45 degree. So I need to know how to find the length of the arc, which I told you in my previous slide. Length of the arc is 2 pi r times theta upon 360. So let's put the values here. 2 times 22 by 7 times r is 7, theta is 45 upon 360. So 7 cancels out, and 45 cancels this 8 times, 2 cancels this 4 times, and 11 and 2. So 11 by 2, that is 5.5 centimeter is the length of the arc. Now to find the perimeter, we know length of arc plus 2r, so that is 5.5 plus double of the radius 7, which gives me 5.5 plus 14, that is 19.5 centimeter is the perimeter of this particular sector. So length of the arc along with the 2 radii, that gives the perimeter of a sector. Likewise, if you have a question based on the segments, so there is a chord, let's draw the figure first. There is a chord AB of a circle of radius 14. So the radius of the circle is already given, say this one and this one. Now this is the chord AB. So the radius is 14. So this is 14. This is also 14 centimeters. Makes a right angle at the center. So see, this angle is 90 degrees. So the chord is subtending an angle of 90 degree at the center of the circle. Find the area of the major and minor segments. So we need to find this area. This is minor segment, and the major segment obviously will be circle minus the minor segment, right? So how to find the area of the minor segment first, that is important. So the central angle is 90 degree. So how do you find this minor segment? Now in this case it will be very easy because you have a right angle triangle in the middle here. So area of a right angle triangle is half into base into height. So for the minor segment, area of minor segment, I will do area of sector, that is pi r square theta upon 360 minus half into base into height, that is r square. Now sin theta is not required here because it is sin 90, and sin 90 is 1, or simply half into base into height, that is half r square. So let's put the values now. Pi is 22 by 7, r is 14 times 14, theta is 90 upon 360 minus half into 14 into 14. So we have to solve this now. 90 cancels this 4 times, 4 cancels this 7 and this 7 times, and 7 cancels out. So you have 22 into 7, 154 in the first part, minus 2 cancels this 7 times, 14 7s are 98. So this comes out to be 56 centimeter square. This is the area of the minor segment. And to find the area of major segment, what do? You take the area of the circle, pi r square, and subtract the area of the minor segment from that. You will get your answer. So 22 by 7 times 14 times 14, which gives me, this is 22 times 28, right? So that is 16, 6, 1 carries 17 and 4, 21, 1, 2 carries 6, 616 minus 56, and that gives me the answer for the question. I think this will be 560, if I am not wrong, 560 centimeters square. That will be area of the major segment. So a little bit of calculations involved, but if you are smart with your calculations, the questions are not going to be tough. Okay. So these are some of the very short and short answer type questions along with the concept of the entire chapter. To look for the next part where I will be taking up little bit, long answer type questions or shaded region questions. Very important video coming up. Till then, share this channel and do subscribe the channel if you have not done it till now. You can click the bell shaped icon if you want to get all the notifications on your mobile itself. Thanks for watching this and all the best for the questions given in the practice worksheet.